Good morning, students. I hope you all are well and good. So, stay at home and be safe. So, today we'll start with the topic coordination chemistry. So, basically, the chemistry is divided into three main branches. First one is organic chemistry, second one is inorganic chemistry, and third one is physical chemistry. So, our today's topic, that is coordination chemistry, belongs to the inorganic chemistry. So here our image is visible to you, and the scientist's name is Werner, and he is the father of coordination chemistry. So next we'll move towards the periodic table. So basically the periodic table is divided into four main blocks. So first one is S block, second one is P block, third one is D block, and fourth one is F block. And for our syllabus we need the D block elements. And one thing, that is, you have to know the atomic numbers from hydrogen to zinc. So now we'll come to D block element, that is scandium has atomic number 21, titanium 22, vanadium 23, chromium 24, manganese 25, ferrous 26, cobalt 27, nickel 28, copper 29, and zinc has the atomic number as 30. So now we'll come to our topic, that is coordination chemistry. Before going to coordination chemistry, we will see what are the molecular compounds. So by taking an example of carnallite, we will see how these molecular compounds are formed. So this carnallite is made up of two salts. One is KCl, another is the magnesium chloride. So here we have to make the solutions of both the salt. So that too in equal proportion. First we have to make the KCl solution, after that MgCl2 solution. So after preparing the solution, we have to mix both the solutions and keep them for evaporation. After evaporation, the crystals are formed, and those crystals are known as the carnallite compounds. So here the molecular compounds are formed. So next, the molecular compounds are of two types. One is the double salt, another is the coordination compound, which is our topic. So first we'll see the double salt. So same, we'll take the example of again the carnallite. So when you place this carnallite into water molecule, so these carnallite will dissociate into, so basically the carnallite is a complex ion, and that complex ion, when you dissolve it in a water molecule, so they will be dissociates into their simpler ions such as the KCl and the MgCl2 salts. So this is what the double salt. So next we'll move towards, which is our main topic, that is coordination complex. So it is a structure consisting of central atom or ion, and which is bounded by the ligands. So here we'll take the example of hexaminocobalt. So cobalt is a central metal ion, and which is surrounded by the array of ammonia. So ammonia is a ligand. And we'll see some terms of this coordination chemistry. So first we'll see, so the metal and the ligand which is present inside the sphere, so that is known as complex ion, and the outside the bracket, so the anion is present, so that anion is known as the counter ion. Okay, so the sphere which separates the complex ion and the counter ion is called the coordination sphere. So here we can see how that ammonia, which has a lone pairs, so that lone pairs are donated by the nitrogens to the respective metal atom. So basically this this ammonia is a monodentate ligand, so it donates the electrons to the central metal atom. Next we'll move towards the coordinate covalent bonds. So how these coordinate covalent bonds are forming. So again the same example we'll take the cobalt, which is surrounded by the ligands, So everywhere ammonia is present. So here the ammonia, this nitrogen has a lone pairs, and these lone pairs are donating to the cobalt atom. And here the mutual sharing is taking place. By mutual sharing, a bond is forming. By the mutual sharing, a bond is forming, and that bond is known as coordinate covalent bond. And here we'll see some terms. The surrounding groups are known as the ligands. Central metal atom is a Lewis acid and ligand is a Lewis base. And in the last example, which one we have seen, that is hexaminocobalt. Hexa, it means total number of ligands present are 6. And that 6 is what we call it as the coordination number. And here the term Lewis acid and Lewis base. We'll see now in our next slide. So here the Lewis acid is defined as the species capable of accepting electron density. It means the Lewis acid, it will accept the electrons from the donor site. And Lewis base, it refers to the capable of donating the electron density. So the element or a metal which accepts the electrons, those are known as the Lewis acid, and the ligand which donates the electrons, those are known as the Lewis base. And the mutual sharing between the Lewis acid and the Lewis base, a adduct is forming. So the adduct is forming, and here the resulting species formed by the combination of Lewis acid and the Lewis base is known as the adduct. So in the next class we will see about the types of ligands. So that one we'll see it in the next class. Thank you.